Hello everyone, so this is an extra recording for some exercise or example I didn't finish in class. So this one is about linear approximation and, tangent plane. So let's briefly review about what is linear approximation. To review, we have tangent plane equation is z equals fab plus fx ab x minus a and plus fy ab y minus b. So this is my tangent plane. A linear approximation is just that, okay, we want to approximate something, and we just use the point close to AB. So LXY at AB is just this guy. It's just the tangent plane. So it's just tangent plane. So it will just be FAB, exact same thing, the exact same thing. So for this one, for any point, any XY near AB, we use this to approximate that value. We use this to approximate that value. Okay, so the exercise is approximate 0.98 to the power 3.03. So in this case, we choose fxy is x to the power y. So in this case, 0.98 and 3.03, so we know that this is near like x equals 1 and y equals 3. So we need to find LXY at 1, 3. So our goal is just LXY near 1, 3 and 0.98 to the power 3.03. It's just close to approximate to L 0.98 and 3.03. Okay, so that's our goal. So LXY near 1, 3, the formula shows us this is F13 and plus Fx13 x minus 1 plus Fy13 and y minus 3. So now we only have to do what is Fx and Fy. So if we have this, Fxy equals x to the power y, this is slightly more difficult function to differentiate, but we try to do this. So for example, Fx will be, if I want to do partial derivative with x, so y is a constant right now. So we don't care about y is just a number. So Fx will just be y x y minus 1. Okay? So now we do Fy. Fy is slightly complicated. So recall, if we have something y equals ax, how to do the differentiation of this one? So if you think this is slightly harder to differentiate, don't worry about this. We can do some trick. So what about we take log on both sides? So we have log y equals log a to the power x, and this thing will be x log a. Then we do implicit differentiation on both sides. So we do implicit differentiation. So we'll have 1 over y times y prime equals log a. So this just be log a. Since we take derivative with x, so finally we will have y prime is log a times y. And y is our ax, so it's log a to the power x. That's it. So this is a quick review how to do this thing. Of course, you can memorize the formula. That's good. But if you don't memorize it, you can use this. Okay. So if we have this x to the power y, x is our a now. A is a number. So Fy, we'll just use the exact same formula will be log x times x to the power y. That's it. So we are using this. In this case, now our a is x is a constant. Okay. So this is my fx and fy. This is my fx and fy. So with this, we can finally happily write our linearization. So LXY will just be F13 is 1 to the power is 1 to the power 3. So 1 to the power 3 plus fx will be 3 times 1 times 3 minus 1, 2, and x minus 1, and plus log x is log 1 times x to the power y. So x to the power y is x to the power y times y minus 3. That is my xy. So this is good. So this will just be 1 plus 3 times 1, 3x minus 1. And log 1 is 0. So this is 0. So everything after that is 0. So we have this. So it'll be 1 plus 3x minus 3. So it'll be 3x minus 2. So this is my LXY. This is my LXY. So this is good. This is good. This is good. So finally, our desired thing is 0.98, 3 to the power 0.3 will be approximate to be L, 0.98, 3.03. So it'll be 0.98 minus 2. So in this case, this will be 9a plus 9a, 1.96 plus 9a, 2.94 minus 2, so 0.94. So we're done. That's it. So this is some exercise about how to do implicit differentiation as well, and how to do linear approximation. But basically follow the same thing. Okay, so this is linear approximation. So that's it. I'll see you in the next video.